Good morning. I know you're probably sleeping at this hour. It's 9 o'clock during the break, and hope you're having a good break. Um, just want to talk about 5.4 exponential functions and differentiation and integration with these exponential functions. The inverse of the natural log function is the natural exponential function. So here's the inverse, and it's called e to the x. And if y equals e to the x, then what we would do is we would take the natural log of both sides. Okay, so if I took the natural log of this side and the natural log of this side, well, these guys will undo each other. Alright, so I'll just get the natural log of y equals x. So the natural log and the e function undo each other. Nice, nice. Inverse relationships, there they are. I just kind of used it. Alright, now I want to solve. Oh, I didn't erase all this. Hold up. You didn't see that. Okay, we're better. Now, let's solve some problems. Let's just take something from like pre-calc. 7 equals e to the x plus 1. And we want to solve for x, obviously. So what I'll do is I'll take the natural log of both sides. So I'll get the natural log of 7 equals x plus 1. Because remember, if I take the natural log of e to the x plus 1, it is just going to give me the power. Alright? And that's because it's e, and that's because the log, the base matches up. So now if I solve for x, I just get the natural log of 7 minus that whole thing minus 1 equals x. Done. Alright, let's try another one. B. And like I said, this was from pre-calc, okay? I don't know how the camera is, but I think it's from pre-calc. So if I tried to solve something like this. Natural log of 2x minus 3 equals 5. Instead of taking the natural log of both sides to undo it, I'm going to take it to the power of e to both sides. So that'll undo these guys. And I'll get 2x minus 3. I usually call that e-ing them. Alright? Equals e to the 5th. And then it's going to be x equals, move the 3 divided by 2, e to the 5th plus 3, all divided by 2. Alright? And remember, e is a number. I think it's 271 something. 2717 to be exact. I'm pretty sure. So that's just basic what you learned probably in FST or pre-calc. And then here's some properties, just some properties of these things. This is what the graph looks like. So the domain is all real numbers. The range, it never reaches 0. So it's from 0 to infinity, not including 0. It is monotonic. It's increasing. It's 1 to 1, concave up, and the limit, and there's your limits, if you will. If I take it to infinity, it goes to infinity. If I take it to negative infinity, it goes to 0. Stuff you've known. Now let's do the calc. Let's look at derivatives. This is the easiest derivative in the book. The derivative of e to the x is e to the x. That's fantastic. However, if it's an expression up top, derivative of e to the u is going to be e to the u, but times whatever the derivative of that u is. That's it. So this is one of the easiest lessons I know. Alright? So here we go. Let's do some questions. Or some problems. E to the 2x. Well, that's an expression, so that's going to be equal to, if I take the derivative, it's going to be equal to e to the 2x minus 1 times the derivative of the top, which is just 2. So I get to write it in a nicer way, e this. There you go. Easy as that. Let's do this one. This is going to be equal to e to the ln of x times the derivative of ln of x, which is 1 over x. Let me get my papers here, just to my security blanket. And this is going to be e to the ln of x all over x. Done. Yes, folks. Would I start the new year with something crazy? Oh, you say here's the sign. Alright, so it's still going to be e to the sine of x times cosine of x. Because the derivative of sine of x is cosine of x. So I would write that probably like this. cosine of x, e sine x. Either way, doesn't matter which way you write it, you know it's commutative. And the last one, ooh, action. All right? And if you, like, for your novice derivative people out there, if you want to do this, u equals negative 3 over x, and then find du, and du would be the same as saying negative 3 to the x minus 1, subtract 1, 3 over x squared. Okay, so we'll get e to the negative 3 over x, 3 over x squared. Done. So I multiplied them both together. And I put it in a u form to kind of show you by novice. I mean, you could do all that with make them u's. The two u's. All right. Anyway, let's continue. Let's do integration. Integration is pretty much the same. The integral of e to the x dx is e to the x plus the constant, and e to u is e to u. So let's see how it works out. Over here, I'm going to set u equal to, now I'll do the u, because I'm nervous. Alright, that's really the bottom line. Du equals 3 dx. Well, I have a dx, so if I do a 3 here and a 1/3 here, looks like I'm golden. Because then that means I have 1/3 e to the u du, which is just 1/3 e to the u plus c. Replace with u now. So the u was 3x plus 1, so my final result is e to the 3x plus 1 all over 3 plus c. Excuse me. I'm almost allergic to this calculus. This stuff. Alright. There we go. So I'm going to do the same thing. This looks a little crazy, but let's let the u fall into place. U equals negative x squared. That means du, take the derivative, is negative 2x dx. Well, holy cow, I have the x there already. So all I have to do is add the negative 2 and divide by the negative 1/2. Done. So you're going to get negative 1/2 the integral of e to the u du. That is one of the easiest integrals to do. Is negative 1/2 e to the u plus c, replace back. So it's going to be negative e to the negative x halves, x squared, I'm sorry, I said x halves, and that's over 2 plus c. Done. Questions? Oh, man. Alright, next one. So here I go. I'm going to set u equal to, oh, I want to stay in red to show you what's not given. Here we go. That was a pretty big eraser. U equals cosine of x. Du is equal to negative sine x dx. And holy cow, I have sine x dx, but I need to make it negative, so I need to make outside negative. Alright? Multiply by negative 1, divide by negative 1, same deal. So you're going to get negative integral of e to the u du, which is just negative e to the cosine of x plus c. I replaced the u back in. Now this one's a little different because this one I'm actually doing a I'm doing a definite integral. So let's see what we got here. If I let u equal everything on the bottom, u equals 1 plus e to the x. When I take the derivative of 1 is 0, but the derivative of e to the x is e to the x. So du is equal to e to the x dx. Holy cow! Look at this. Oh, I wanted the green one. Yes, yes. There he is. I have it. So now, this just turns out to be, if I'm right, 1 to 0, 1 over u du. Well, I'm going to change the limits of integration. Remember, if I'm going to deal with u, I'm going to change them. So now, if I plug 1 in for x here, you know what? Let me not change it because it looks like it's going to get ugly. So, you see how I stopped? That's what you guys got to do. You got to talk about it and say, Oh, if I put it in, it looks like it's going to get ugly. I don't know. So that's what I'm doing. I'm stopping there. I'll take the derivative. Oh, 1 over u, if you haven't forgotten. We didn't have too much eggnog. That's natural log of u, all evaluated at 1 and 0. I'm going to replace, I have to replace u back because I'm using 1 and 0. So it's the natural log of 1 plus e to the x, and it's from 1 to 0. We're going to go and evaluate it. So I'm going to get natural log of 1 plus e minus, well, when I put in 0, I get natural log of 2. So I get natural log of 2. That's how I would leave it, folks. If I have no calculator, if I have a calculator, it comes out to like 0.620 if I have one. But if I don't have a calculator, you leave it like that. I bet you're wondering what if I did change those limits of integration. Maybe you're not wondering that at all. I don't know. But if I did, this would be 1 plus e to the 1 plus e, and this would be, if I plug in 0 into here, would be 2. So when I go ahead and did ln of u, I would have 1 plus e to put in, which would be this, and then I would have 2 down here, which would be this. So it works out. Yes! All right, I've got something for you to try. All right? I know you have your 8-piece set, and I'm going to have you try a couple here. All right? Not all of this, please. It's way too much before the new year, of course. We're going to take that out. 39 to 57. Let me take a look. Let me take a look at these. Let's see. You can do 39. Wow, they're all kind of different. Wow. 39 to 45 is pretty good. Odd. 57's a little much, folks. I'm looking. Just let me look, would you? Oh, they're good problems, though. I'll leave it. I'll leave it like that, I guess. I don't know. Let me look at my paper. Well, this is how much it was. That's it. It was 1 page for me. Might be about 2 pages for you. Let's keep it like that. Let's go like that. That's good. All right. Well, I hope you have a happy New Year. You know, be safe, and can't wait to see you on Wednesday. I'm jonesing for you guys already. I'm home alone today. Been with the wife for the past week. Family stuff. So hopefully you've been doing the same. So take it easy. Enjoy.